So we have complex fractions. This has absolutely nothing to do with complex numbers and i's, if that's what the word complex brought up, which good on you, because that's what it should bring up in math, not this nonsense. So a complex fraction is a fraction in which the numerator and denominator contains one or more terms with fractions. So complex fractions are what happens when one person is reading a problem and the other person is writing, and you get a mess. This is horrible writing for math. If I said 25/42 divided by 15/28, you would not write it as one giant fraction. You would write it with an old school division symbol. And then there's this madness. So we can like common denominator the tops together, common denominator the bottom stuff together, and then change the division to multiplying by the reciprocal. But there happens to be a nicer way. And that's what this little craziness here is talking about. I can multiply the top of the fraction and the bottom of a fraction by a convenient number over number. As long as it's the same number, I'm multiplying by a crazy form of 1. So this talks about figuring out the least common multiple. But if you don't see the least common multiple, you can do it in several steps. And I saw you guys doing that in your work on the test, which good job. There's no reason to divide by 4 if you notice 2 and then 2 again. All right, so 42 and 28. They are both even, but I happen to be more comfortable with my 7s. They're also 7s. So I'm going to multiply by 7 over 7. So on top here, I'm going to sneak the over 1s in there. We usually don't write them, but it can help you to see them as little fraction, little fraction, little fraction, little fraction. All right, so don't do 25 times 7. I know 7/4, but 7 goes into that 42. That's why we picked 7, so that's what we're going to do. Goes in there 6 times, and then here 7 goes into 28 4 times. So now we have 25 6 over 15/4. Notice when I rewrote it, I made the middle fraction bar bigger. That is one of my, oh my God, pet peeves about these things, is that you can't tell like which one was which order when you write a crazy complex fraction like that. In the book, they will make the effort to write the middle line a little bigger, which implies that is the outermost or last operation. So any complex fraction like this, there's assumed to be parentheses around the entire top and the entire bottom. If you were going to type this on the calculator, you would put parentheses around the top and parentheses around the bottom, put the division in the middle, and it crunches it for you. So there is no reason to do this insanity. But for completion, in case it shows up in Alex. So now 6 and 4 are both divisible by 2. But right now, 25 6 and 15/4 is not that crazy to look at. You could change this into the old school division symbol and then do the fraction division, keep, change, flip. But just for kind of completion and showing you the ridiculous method, I could multiply by 2's here. 2 goes into the 6 3 times, 2 goes into the 4 2 times. So I now have 25/3. I'm going to go ahead and change that fraction bar to old school division. And now it is 15/2 on the bottom. I'm going to go ahead and put those parentheses in because they should be there. So 25/3 divided by 15/2. So it's 2 fractions, so keep, change, flip. Keep the 25/3. Change it to multiplication now. And then keep the, flip the 15/2, so now it's 2/15. I should have multiplied by something bigger, but 42 and 28 are ugly numbers. Okay, we'll finish this and then I'll show you what I was babbling about. So divide by 5 is 3, divide by 5 is 5, so 10/9. Okay, so I was multiplying by the greatest common factors, which does work, but if you can figure out the least common multiple, then the little fractions are all going to disappear. The problem is sometimes that number is really big. So we have 4 sevens and 6 sevens. So 4 and 6 both go into 12 sevens. 12 sevens is 70 and 14, 84. So we're going to multiply the top and the bottom of this craziness by 84. So I did make a boo-boo, but we are going to turn it into a lovely learning opportunity comparison. All right. So the reason we picked 84 is because 42 divides nicely into 84. It is in fact twice. So this is now a 1 on the bottom, and this is now just a 2. Then down here, 28 goes into 84 3 times. So this is now a 1, and this is a 3. So now I have 25 times 2 over 1 times 1, which is 1, and over 1, we don't have to write. So this now becomes 50 over, and then 15, 1's on the bottom, times 3 is 45. Both of those are divisible by 5. So this reduces to 10/9. 10/9. Now let me zoom out a bit. So the method on the right is more superior, but it's a little bit weird to think about. So it is not a surprise if you've never seen that method before, or even if you have and it was just really confusing. Like me as a mathematician, my brain will do the left more often than it will do the right here. But the right is more efficient, and it gets rid of the little fractions in the big giant fraction. It's also a really useful tool in algebra, but we should not see that because it's bad enough doing it with numbers. So fingers crossed. If it, we'll cross that bridge if we get to it. All right, number 10 is a little fraction over another little fraction that happen to have a's in them. So we are going to multiply the top and the bottom by the least common multiple, or the common denominator, which in this case is a, because that's what they both have. So we're multiplying by a over a. That's why I'm supposed to slow down. So we are just left with negative 18 over 24. Both of those are divisible by 6, so this becomes negative 3/4. This is where the multiplying by the common denominator is very powerful. So it has to be the common denominator of all the crazy fractions you see. So 12 and 6, certainly 12 would be the common denominator, but now I got to mix that up with 9. So 9 and 12 both have 3's in them. The 9 has an extra 3 that the 12 does not, when we're thinking in them as numbers that multiply to get it. So 12 times 3 is 36. 9 goes into 36, 12 goes into 36, 6 goes into 36. There's our magic number. Now, in order to do this, because we've got subtraction and addition on the top and the bottom, this 36 on the top and the 36 on the bottom has to distribute to everything. including the 3. Even though the 3 did not have a denominator, if we're going to multiply by the crazy form of 1, everybody's got to get it. It has to be equal, so it is the same. So I'm going to go ahead and write that. So give me the blue. So we have 5/9 minus 1/12 big over 3, leave a space, plus 1/6. And now I'm going to go in and write times 36 everywhere. You can write 36 over 1 if that helps. It's totally fine. All right, now, magic trick. So the 9 goes into the 36 4 times. That is now just 5 times 4, so we have 20. Minus 12 goes into 36 3 times. 1 times 3 is 3. 336 is, whoo, that is 90 and 18, 108. Plus the 6 goes into the 36 6 times. Poof. Now we just have the one big fraction. All the little fractions are gone. There's another way we can do this when we start looking at equations that will get rid of all the fractions in the same way. Figure out the common denominator of all your fractions and multiply everything by it. So now we just got to clean this up. 20 minus 3 is 17, which prime, so that means whatever we get is what we get. 108 plus 6 is 114. Now my brain looks at that and it's like 7, it should be divisible by 7. It's not. 17 is prime. We should check to see if 17 goes into 11/4, 114. Don't think it will. No, it does not nicely, so we are done. So we just have the last one here, number 12. This one's a little nicer though, because 2 and 5 both go into 10, so 10 is our common denominator. Now, some people, when they do a problem like this, and I'm going to zoom in a bunch to show you, they just squeeze the numbers into the problem. So this is shortcutting quite a bit of work, but it's not wrong. And if you watch any videos, you might see someone do this. All right, now we'll just deal with each little product we've created. The 10 and the 10 cancel, so this is now a 7. The original had a plus, and then 3 times 10 is 30. Over. 5 goes into the 10 twice. 2 times 2 is 4. Plus 2 goes into 10 5 times. 1 times 5 is 5. So we are going to get 37 over 9. 9 is 3 times 3, but 37, 3 plus 7 is 10, which is not divisible by 3. 37 is not divisible by 3. That is the answer. Some disgusting fraction a little bit bigger than 4. Whew. All right. We'll pause and come back with a new video.